I'm going to present today a very short summary of a new capability under Aviso Amira platform with regards to the correlative modalities that we have been working on. A very short overview of the presentation. I'm going to introduce the cosmic model for Aviso Amira. Cosmic stands for the Correlative Spectroscopy and Microscopy Toolkit, and a very short presentation on a use case. It was a collaboration with the IECB and IMCB CNRS here near Bordeaux on new biocomposites for bone and tissue engineering. After that, I will very shortly present regressive and iterative DECT methodologies for enhancing the contrast for biomaterial studies, and at the end, one, I would say, collaboration proposal that we can discuss afterwards. Therefore, very shortly, what COSMIC is. Under Aviso Amira platform, we have begun to develop an automatized way of having spectroscopic and microscopy imaging automatized, meaning that the user will have a unique interface under Aviso or Amira. At the beginning, we were doing the development for material science, and now we are extending it to life sciences. And this model goes hand by hand with a software integrated cross-platform sample holder. And the user will be able to get in data from scanners and confocal spectrometers in specific models that we have yet developed. We have mainly worked on the Raman, but we are extending it to X-ray fluorescence and diffraction as well. But for the moment, it's mainly Raman, and it will be extended to X-ray fluorescence. One very important extra information, the model is generic with regards to the CT scanner and the spectrometers, but it's dependent on the Thermo Fisher dual beads. Now, and the user will be able to simply, once the spectroscopic measurement is done or the micro CT measurement is done, can simply put the sample inside the dual beam, and the model will allow the user to automatically define any number of regions of interest within the volume of the confocal scanned sample or the CT volume. And those arrays will be automatically pattern digged, prepared, sent for the to slice and view. All the data gets back, fused, and visualized and quantified. Therefore, that's mainly what COSMIC does. It is currently available under what we call the non-standard request for Aviso Amira, and hopefully within the near future will become a standard model. Simply now going to a very simple use case, which only is simple, I would say, at the first glance. The ICMCB CNRS has developed about 3 years ago in 2018 a new kind of ceramics which are calcium-based hydroxyapatites for bone and tissue engineering. And the procedure was a kind of mixture of freeze casting and sintering at high pressure. Now, the problematic with these kind of materials were that they have to have at the same time extremely good thermomechanical properties, but they're extremely highly porous. Therefore, the porosity in these materials are mainly above 94%, and porosities are multi-scale, and the distribution of pores within the walls, both in size, morphology, and connectivity, defines the material's properties. Now, the problematic is that the manufacturing process will necessarily induce defects in the walls, and these defects and the kind of porosities that will be produced will affect directly the mechanical properties. Therefore, the purpose of this study was to determine how we can relate the multi-scale porous media properties to mechanical variations, and after that optimize the manufacturing process. Now, when we got the sample at the beginning, we have simply done a pre-evaluation of homogeneity and impurity of the sample. We have done multiple 3D Raman on the surface of the sample, for about 50 microns depth in a stochastic way, and we have used a first order upscaling homogenization to create a normalized density map to see if the sample on which we are going to conduct the correlative study is, at least at first approximation, homogeneous in phase and not with too much impurities. And here I've simply put an example of data fusion, which has been done nearly automatically between 3D Raman and micro CT data. And you can see that the sample is at the beginning quite big. It's 4 by 4 by 6 millimeter cube. Once this is done, we have conducted multi-scale CT. Therefore, we have chosen a zone where we have pores and cracks of various types and scales, and a first low resolution micro CT at around 2.35 micron per pixel. And after that, we have chosen a central zone where we thought that the concentration of different type of defects would be interesting to be studied. And we have done a higher resolution micro CT as about 0.84 micron per pixel. And the HeliScan, which is the Thermo Fisher, I would say, micro CT, has an internal automatized multi-scale CT correlation. Therefore, this part comes directly from the OT-scan and is independent to Cosmic, and it's a preliminary which allow us to go from very big samples to extremely small samples if needed automatically. But if you don't have, I would say, Thermo Fisher HeliScans with any kind of micro CT that allows ROA scanning, that can also work without any problem. Once this is done, we have chosen a small area within the walls where we identified interesting features to look for. And here where the Cosmic comes in, which will allow direct automatization from high resolution CT to the dual beam scanning. And here we have nearly 50 nanometer in pixel size in plane, and we have nearly 933 slices with a 15 nanometer thickness in a zone which is quite okay for these kind of studies. Now, this has been done with the size dual beam. If you do it with a plasma fib, it will be nearly 10 to 15 times, I would say, faster. Now, once this is done, I will simply show you some information that we can get out from the FibSim scanning. We can identify and study the walls topologies, the localization of densified zones within the walls. We can go for the tortuosity studies. Therefore, many different kind of information which are important for the mechanical properties calculations can be extracted directly using the Aviso Amira. And at the end, near the zones where we have done the auto slice and view, we can prepare lamellas and go for the studies of the extremely small porosities within using a TEM. And that's also where the Cosmic comes from, getting the complete locking of all the coordinates from the micro CT to the lamella prepared for the TEM. Now, I've summarized all these steps within a schematic workflow. This study has been published in 2018 in Journal of Functional Biomaterials, and I've simply gave here an example of what we can calculate. Here, I've simply put the pore equivalent cylindrical diameter that goes from several tens of microns to tens of nanometers, and we can also calculate the connectivities, the orientation tensors, the morphologies, and many other aspects which are needed. This is mainly a very short introduction to the Cosmic as one of the simple use cases. I would also like to introduce a very short example to what we have developed as well within the different platforms that we have, the Pergeos, the Amira, and the Aviso. We have implemented what we call the regressive and iterative DECT with generic sample references, some for material science, some for specific cases in life sciences. And here you have a mouse heart embedded in resin, and you can see the comparison between DECT and no DECT studies. You have some non-segmentable regions which are mixture of tissue and resin, and with the DECT we can segment them quite easily. And that's a orthogonal section, and I can go to a simple 3D view that you are all familiar, that we can get from Aviso Amira visualization. Therefore, that can also be discussed if one is interested to set up a collaboration to test few samples. At the end, I wanted to simply put in this, I would say, collaboration proposal. We would like to propose a kind of alternative procedure for some of the existing workflows between the fluorescence and micro-CT, with some modified ways of embedding in the resin. Therefore, the Cosmic model can be adapted to the 3D X-ray fluorescence with a new procedure for resin embedding, and after that, instead of simple micro-CT, using the DECT plugin that will be available under Amira. Therefore, that's mainly a collaboration proposal. If any I would say research proposal that you may have that can use this kind of workflows, we are eager to I would say to collaborate on. Thank you very much for your time and for listening and interest. If you have any questions, please. Thank you very much.